All right, hi guys. My name is Don Crowley. My project is named To Catch a Bluff. I am an online student. I'm in the Masters of Data Science program, and this is my last class in the entire program. All right, so first of all, the goal of this project was to detect a bluff from a picture of a poker player's face. So basically, I made this data set myself. I watched a whole bunch of like poker on YouTube. There's a lot of it recorded. Went through and took a bunch of screenshots of players during play. Um, some the two types of screenshots were either a bluff or a non-bluff. Some of the methods I used in this paper were the Eigenface method, the Fisher face method, and I used a neural network as well to make predictions. So first of all, let's talk about what I was looking for. So what does a bluff look like? So in this picture here, you can see that Joseph has Queen 10, and Mike has pair of sixes. Mike's got the better hand. Um, Joseph likely knows this. He's a professional poker player. He realizes that none of his cards have hit anything on the board. Uh, he has just made a bet, basically to bluff Mike out of the game. Joseph thinks he's got the worst hand. He's making a bet because the only way he's going to win this particular hand is to fool Mike into thinking he's got stronger cards than he does. So when I took the screenshot of each player, I took this screenshot of their face immediately after they played their card. All right, so the first method I tried was the Eigenface method. Eigenface method makes use of a a high dimensional face space with based on the eigenvectors and the principal components of all the images. Um, the way I did this for predictions was I created this face space with all the images, but I left out a test image. Made a prediction for that test image based on the nearest neighbors. I used a k value equal to 1. I could have used 3 or 5, but 1 was what I chose for this. And so I went through image by image and made the prediction for each individual image based on its nearest neighbor in the high dimensional face space of all the other images. So this approach had an 82% accuracy, which sounds good, but isn't quite as good as it sounds. This was a pretty unbalanced data set, so a real like straight up bluff is relatively rare in poker. So for my data set, I had 15 bluffs and I think about 50 non bluff pictures. So the data set is unbalanced. I think it's like 78% non bluffs. So getting an 82% accuracy on a data set that's balanced unbalanced 78 to 22 isn't actually that good. And looking further at the details of the prediction, I did an especially poor job of predicting actual bluffs here. So what that tells us is the eigenface method isn't really something we can utilize to predict bluffs. Next, I think we'll look at the Fisher face approach. Um, so the couple differences between Fisher face and Eigenface. The Fisher face approach uses LDA as opposed to PCA, and the idea that makes the Fisher face approach generally better is that it creates a wider scatter between classes, but a smaller scatter within classes. So that means that um, the in this high dimensional space, the bluffs should be closer together, and the non bluffs should be closer to the other non bluffs, and then there should maximize the space between the bluffs and the non bluffs. Uh, Unfortunately, I couldn't quite get the code to work for the predictions. Um, I couldn't get it to work in time for this presentation. I think in general, because the eigenface method works so poorly, there's not really much to in here to make us think that the Fisher face approach would work all that much better. Next thing I used was a neural network. I kind of modified the GoogleNet neural network for my task here. So the GoogleNet neural network was big breakthrough as far as being able to classify objects. There was an online challenge where this set a new record for best ability to classify. It was built with a training set of over 1 million images with 1,000 different classes of images. So cars, apples, etc. I was able to modify this a little bit to just kind of use the pre-trained network, but have it differentiate between bluffs and non-bluffs. It actually worked oddly well, which I was suspicious about. So you can see here this guy on the left here was bluffing, and it assigned a 71.9% estimate that he was bluffing, and the percentages actually seemed okay. Anyways, to do this, I split the data 70-30 and ran 10 iterations of the network. Really kind of depended by iteration how well it worked. So sometimes it was almost 95% accurate. Sometimes it was less accurate than my Fisher face approach. So we'll kind of talk about our conclusions on that a little bit later. So overall, this was a pretty difficult problem. My data set was small. I just didn't have time to collect 1 million images like the GoogleNet process. And then it's also pretty difficult, looking at these two images. I know that neither one of these guys is bluffing, but it's not as easy as identifying like a dog as opposed to a cat. The eigenface or the Fisher face or the neural network would have to pick up something that it's pretty difficult to see as a human. So the conclusions we had from this, the eigenface approach wasn't really useful. I don't think the Fisher face approach would have been especially useful either. Neural networks did show some promise. One of the tough things about neural networks is it just doesn't it's pretty difficult to get to the bottom of what's what it's looking at, like what it's picking up. My hope was with the eigenface and the Fisher face, it would be pretty, those would help me kind of identify some of the important features in the face sets. But if you go back and look at the Fisher face, it didn't really point to anything, and I'm a little bit wary of using anything from those two approaches just because they really didn't work. In general, maybe this problem just wasn't solvable based on a data set like this. There are other things that go into bluffing and picking up on a bluff, like body language or movements as opposed to static pictures. Anyways, further work like the neural network did was kind of interesting. May have shown some promise. I was working with OpenCV a little bit. OpenCV has been used for like emotion detection, and I was really hoping to get that to work, but I just couldn't. I didn't get anything from that was worth presenting in here, but I would like to work with it some more. And then, I think really the weakness here was my data set was so small. It's pretty time consuming to sit down and watch a YouTube video of poker and wait for the right moment to catch a bluff. I just kind of ran out of time to make I didn't have time to make a much bigger data set. So I think in the future, if I keep working on this, I can just keep increasing the size of the data set and see what becomes of it. So anyways, thank you. That's my presentation.